Hello guys, welcome back to this part 2 for the design of a G+3 story office building. So in the last part we stopped whereby we had just imported our model into Etabs as you can see. So in this part, in this tutorial, we are going to proceed with modeling with a few things like the trusses, model the floors, define materials. Yeah. So without wasting much time, let us proceed. So now here is Etabs. We have on the right we have the model explorer. In the middle, it can be used to view the plan views. Then on the sides, it can be used to view the 3D or elevation views. Now, the first thing I normally do is to come to define, click on define materials, add new. So depending on the country and the codes you're going to use. So I'm going to use Europe. Then I'll choose steel. Then the standard will be Eurocode 1993 part 1. Then grade. Now I'll choose here the grade of my steel depending on the manufacturer. So in my country, most manufacturers make a grade S 235. Then I'll say okay. I'll come and say okay. So it has been defined. Then I also come add new Europe. This time around I'm going to add concrete. So I'll first choose class 2530. So what 25 stroke 30 means? 25 is the cylinder strength and 30 is the tube strength. In other words, when you take this concrete for testing, in case you take a cylinder, you're supposed to have at least 25 Newton per millimeter squared or MPa by the 28th day or 30 MPa by the 28th day if it is a tube. So I'll press OK. Then here I'll come to material damping properties. So I prefer using 5%, which is 0.05. Okay. Then I'll also add new. I'll add another 30 strokes 37. Material damping. Also, you can come here and check material property design data. You see our specified concrete compressive strength FC is 30. Okay. Now I'm also going to define the rebar or reinforcements. I'll come to new. I'll change this material type to rebar. I'll say okay. I'll give it a name FYK 500. I'll come to modify structure material property design that I'll put this to 500. Also grade, I'll call it grade 500. Okay. Then I'm also going to define the aluminium properties for the curtain wall. So I'll come to add new aluminium. Okay. So I'll call it. I'll first come here to modify property design data. Aluminium type, I will leave it to route. Designation, yield compressive strength, I'll leave it the way it is. I'll even leave the title to aluminium. Say okay. Then I'll also define all deform this All deformed, steel, define. I'll also leave it at that and that. Then I'll say, okay. So I'm done with defining the materials I'm likely going to use. So now what I need to define right now is I need to define the section properties. So I'll come to define section properties. Of course, I will start with the existing beams and columns. So this is beam 250 by 500. I'll say modify. I'll leave the name at is. Material, I'm going to use C2530. I'll change it using this drop down arrow. Depth is okay. Modify property modifiers. Now this one's cross section area, I'm going to leave it at 1. What this one means that it is 100% of the cross section, like the actual area. But then shear area in direction 2 2. You can see this is direction 2 2. And normally under normal construction or real life, not due to irregularities and inaccuracies, it is hard to completely utilize the entire area of the cross section. So for safety reasons, we prefer designing it as if we're going to use 50%, which is 0.5%, which is 0.5. Even shear in direction 2, direction 3, we also assume you're going to use only 50% of this area. Some may just be wasted. That is the safest way of designing. Regional constant, we take 10%, which is 0.1. Moment, we also assume only moment of inertia. Moment will only be active on about 50% of the section. 50%. So this is the safest way. The mass, we leave it at 100% of the section and the weight. Okay, then come to reinforcement, modify structural rebar. Ensure that it's reading M design beam only, not column. Change the material of the longitudinal rebars, the main reinforcement to FY 500. Even the confinement bars and bracket ties also change it to 500. Top bars. Now this is longitudinal rebar centroid. Now if I get my calculator here, now this is where you use cover, assuming we are going to use rear cover of 25 millimeters, assuming we are going to use 80 millimeter bar for confinement bars, so plus 8. And assuming my main reinforcement is going to be 20, sorry, H16. In other words, bar with the diameter of 16. So I'll take half of 16, which is 8. So plus, I'll say plus 8. So it gives me 41. So I'll come here, put in 41. 41. I'll leave the others the way they are. I'll say okay. Okay. Then I'll come to define this column. Okay, let me first finish all the beams. I'll come to ring beam, change the material to C25. I'm going to do this faster. Then I'll go to the next beam. Then now also come to columns, to the existing column, and also try to modify it. I'll change the material to C. Okay, let me first try and see if 2530 will pass. I'll first leave the dimensions. Then I'll come to modifier. Still, only 50% of the area is used for shear. 50% of the area, 0.1, so, which is 10% of the area. 50%, 50%. Okay. Come to reinforcement. Now, this time round, ensure that is using MP to MP, sorry, PM to M3 design, bracket should be column. This one, not beams. Then confinement bars, longitudinal bars, ensure that is FY 500, even this. The section is rectangular. We are going to use ties, not spiral. Reinforcement, we have two options: to be checked and to be designed. Now, when you use to be checked, this is when you're checking an already designed building. You want to see if the reinforcement is sufficient. But for to be designed is like for our case whereby we don't know the reinforcement which might be needed, so we check it. We check or use reinforcement to be designed. Now, clear confinement, clear cover for confinement bars. So, like 25 millimeters. So I'll show you how they get these uh, covers. Number of longitudinal bars. These ones you can first leave them at default. Maybe let's take 16. Corner bars also 16. Confinement bars, let's take 8. Okay, okay. Now, even here, okay. Come back again to define section properties. Now, let's define the slab sections. I'm going to start by modifying my stair slabs. You remember this? So modify. So I'll give it a concrete grade of 2530. It should be shell thin. Now the difference between shell thin, thick, membrane, and layered is that for shell thin, this is the normal behavior of a slab whereby it receives loads, takes up or consumes up a certain percentage of the loads, then distributes the others to the supporting columns or beams. Now, shell thick is used for these slabs which are strong enough to withstand or completely neutralize the effect of loads imposed on them. They are strong in such a way that they uh, only a very, very small percentage of the loads imposed on them are taken up into columns and beams. Then for shell membrane, okay, now for membrane, now this is used as a conservative for designing beams and columns or trusses, whereby a membrane, it doesn't take up any load. In other words, all the loads imposed on it are completely distributed to the supporting members such as beams and columns. Now this is used, let's say if you're designing trusses and you want to put something to appear like maybe a roof sheet, whereby we all know that roof sheets don't take up loads. They are just surfaces or membranes. So all the loads imposed on them, like wind, are supposed to be directly taken up by the trusses into supporting beams, then into columns. Now layered is used, let's say if you're designing the ground floor slab, which has different layers such as concrete, hard core, soil. That's when you use that option. So for our case, we are going to use shell thin. Now slab. Under type here we have slab, ropes, stiff ribbed waffle mat, and footing. So we are going to use a slab. Thickness is 200. By then now I need to show you how we are going to come up with the correct thickness of these stairs. So for the meantime, I'm going to first leave it at okay. Okay. Then also come to define sections, slab sections. Now we are going to add a new property. I'll call it 200 millimeter hollow, sorry, ribbed slab. Material C2530. Type shell thin. Modeling, I'm going to take it to ribbed. So I'll leave the overall depth at 200. Slab thickness, I'll leave it at 50. I'm going to show you very soon how I came up with this. Stem width at the top, I'll put 450. At the bottom, 150. Rib spacing 450. I'll say okay. I'll add a new slab. I'll call it 200 mm solid slab. The material is 2530. Shell thin, I'll leave this at 200. I'll say okay. Then okay. So this is how we define the sections and materials. Then let me see how. Now remember we also need to define sections for the trusses. So what I do, I normally go to the manufacturer's catalog and I see the available sections which they might use, let's say in our country. Then I define those sections according to the manufacturer's catalog. So let me first open one of our manufacturers around this region. So this is a roofing's group. So I will scroll up until I see the hollow sections. I'll maximize. So here I'm saying has recently installed the first tube milling. That is useless. Finished tubes are strapped in bundles of square, rectangular, and hexagonal shapes for stability when stacking or loading onto various modes of transportation. Standard length is 6 meters. Minimum length is 4 meters. Maximum length is 6 meters. Then these are technical specifications for round tubes. I don't want the round ones. And these are technical specifications for square tubes. Then these are technical specifications for rectangular tubes. And these are technical specifications for structural tubes. Now the difference between here structural and um, just square tubes is that when these now they use the grade of 210. Tensile strength is 340. Minimum yield strength is 210. So we need to go and update if at all we are to use this manufacturer. The difference between structure and non-structure is that for structure, they can now these ones can be used as beams and columns. However, if I look at the applications for tubes, here they are saying manufact furniture fabrication of wheelbarrows, burglar proof, and grill bars, structures for tents, applications for door, sizes such as 60 by 40, and both build spines and rafters for light commercial building. So let us now define the sections. So I'm going to use 40, 50, and 60. That's what I'm going to define. But then this now typically depends on your manufacturer. So feel free to visit a few catalogs and you see the available sections. So I'll come to define frame sections. I'll say add new. It is here I have an option of an I-beam, assist channel, a box tube. So I'm going to take box tube, which is a hollow section, a square hollow section. Then here it will come. So I'll put in the name SH 40 by 40 by 1.5. So I'm taking up this one. I'm starting with this. Alternatively, you can use the steel tables, let's say like the universal columns and universal beams tables. So the grade is 325, but then I need to change this. So to change this, because we saw that this sign, their tensile strength is 340, their minimum yield stress is 210. So we need to change this to be in line. So I'm first going to come to this, add the material. I'll come to this, I'll say modify. So it is S210. Then I'll come to modify design property data. They are saying minimum yield stress. So the minimum yield stress is 210. So I'll change this to 210. Then tensile strength is 340. So I'll come and change this to minimum tensile strength of 340. The distance 210. I'll say okay. Okay. So I'll leave this now to S210. So the depth is 40 millimeters. Even this is 40 millimeters. Flange thickness is 1.5. Say, oh, hold on. Modify. Web thickness is also 1.5. I'll say okay. Then I won't go to add new. I'll come to add copy property. So this is like duplicating. So I'll put in SH 40 by 40 by 2. So the rest remain the same. Only this changes. Add copy. SH 40 by 40 by 3. 3. 3. and copy. Now go to message 50 by 50 by 1.5. This is 50. This is 50. 1.5. 1.5. Contrast. Then add the copy. Press Ctrl V. And this 2. This should be 2. This should be 2. Add the copy. Ctrl V. This should be 3. This should be 3. And this should be 3. Add the copy. Now I'm going to use to these ones 60 by 60. Now these ones they have only 2 and 3 millimeters. This is the wall thickness, which is like the flange and web thickness. So Ctrl V. So this is 60 by 60 by 2. By 2. Okay. P. Search square hollow section 60 by 60 by 3. So 3. 3. Okay. Now I have defined these all sections I'm going to use for the trusses. Then I need to define an automatic selection section, whereby the computer will automatically decide for me the appropriate section to use. So to do that, you come to add a new property. You select auto select selection list. I'm going to call it under here draw still automatic. So under selection shape, ensure that it is reading auto select. Then get these still sections, click on the first one, click on the last one, use this arrow to say add. Alternatively, you can say import more if you have. Let's see what is here, like the default ones, in case you want, but I don't want. I want to use the ones I've defined because these are the ones I can easily get from my manufacturers. I'll say okay. Now this section has been defined. Okay. Now at this stage, I'm now ready to start sketching. If you think like the slabs, the trusses, and the curtain wall around the building. So let me first open Revit and show you something. Now to sketch let's start with floors. I prefer having these things colored. Now what you do, you can press Ctrl W on your keyboard to open up the visibility options, or you can come to you can click on this icon here, or you can come to edit. In fact, you can come to view and set display options. So there are three ways. Then um, all I need is just change this view by colors, change it to section. Say apply. Okay. You can now see this slab has turned to blue. So first opening Etabs because I want to show you something. Now, when I open one of these DWGs, you realize that we have panels. On this panel here, it's an office area. But then this side, it's where we have washrooms. Then here we have a landing for the lift shaft and the stairs. And then the other areas are just office areas. Let me see the second floor. Basically, same for the second floor, except um, this panel here between 2, 3 and this. So I have a toilet. In fact, from 2, 5. So what does it mean? Here we shall have solid floors. By then, the rest of the panels we shall have ribbed slabs. Okay, so having understood that, let me go to Etabs. Now I need first define something small. I'll come to edit, come to add edit stories and grid systems, modify the story data. Now, what you do under first floor, make sure it is a master story, so change it to yes. Then make the second floor similar to first floor. So we made the first floor a master story, then we made the second floor similar to first floor. So this will save our time while sketching. So I'll come to this one, change this option of one story here. I put two similar stories. Then I'll come to slab, this option of a complete rectangle. I'll change the type to 400 millimeter ribbed slab. Then I'll come to the first corner here, drag onto the second one. Oh, sorry. I need to be on the first floor, which is the master story. So you should be paying attention on the 3D. You see how things are developing. Make sure this is similar stories as earlier on agreed. Sketch this. You see how two floors or slabs have been formed. Come to this. Come to this. Now here I exceeded a little bit, so I press Ctrl Z to undo this. You see I'm at grid point 3B. So I'll go to the next grid point. This. Then for this other panel, we saw that this is a solid slab because we have washrooms at this point. So I'll change the property to 200 solid slab. I'll come and select this point. Now for this one here, it's where we have our floor, and also we have stairs around here. So I'm first going to leave this blank, then we shall put a beam and a beam such that we are able to sketch our slab appropriately without any errors. So after sketching, I'm going to come to edit stories, modify. I will now take this one to default. It will no longer be a master story. Say okay. Then I'll change this one to one story. Then I come to the second floor, because we saw in our second floor that from grid 2, 5, they are all solid slabs. So to change this into solid slabs, I'll click on 1 and this, assign, come to shell, slab section. We are assigning a 200 millimeter solid slab. Let me drag this. I'll click apply. See how it has changed. I'll say okay. So I'll say Control S, save. Now to remove these displays, come to assign, click on clear display of assigns. So it goes. So guys, for this tutorial, I'll be stopping from here. In the next one, we shall learn how to model the trusses. We shall continue from this and model the trusses around the building, the roof trusses, the trusses at the entry canopy here. We shall definitely put the iron sheets and also model the curtain wall panels around the building. So guys, thanks for watching. Please don't forget to like and subscribe. Bye.